Okay, this is an introduction to the course Elementary Stereology for Quantitative Microscopy. This is being given by Professor Sandeep Sangal and Professor S. Shankaran from IIT Kanpur and IIT Madras respectively. This course will discuss the techniques used for quantitative characterization of microstructures, and it will be focused on the geometrical characterization of such microstructures. Why is it important to characterize the microstructures geometrically? Is that many of the properties of the material depends on the morphology of the microstructure. For example, in a polycrystalline structure, grain size distribution, particle size distribution become important, and on the processing side there is a strong correlation of the morphology of the microstructure that gets developed as a result of controlling some of the processing variables. So, this course will look at the geometrical characterization of grain size, it will look at particle sizes, it will look at interlamellar spacing of lamellar structures, it will look at dihedral angles. These are the angles between grain boundaries at triple points and at triple edges. It will also look at such things like materials which have been subjected to thermomechanical processing and as a result have developed some kind of a geometrical texture or a geometrical orientation, then how to quantitatively analyze these microstructures as well. The underlying technique for quantitative microscopy is stereology, and here we will look at the elementary stereological tools. Stereology is strongly based on mathematics and probability and statistics, because the microstructures that you are trying to quantify are stochastic in nature, and hence they have to be dealt with through statistical methods. The microstructure itself may have a very complex morphology, but stereology will provide very straightforward and simple tools to implement in order to quantify certain parameters of the structure. Now, the course will also look at the data that one collects when one makes measurements on the microstructure, and how to analyze this data statistically and look at the nature of the statistical errors. Now, who can benefit by attending such a course? This course would be very useful for students of metallurgy and material science. This course would be very useful for industry personnel who are involved in some kind of a microstructural quantification in R&D as well as quality control. And the course may also have certain benefits for people working in the area of life sciences. The course will also provide a theoretical background to the statistical tools and will also provide adequate tutorials in order to clearly make the student of this course understand how to implement the characterization techniques properly. And in this introductory lecture, I will also introduce some of the references that could be useful for people working in the area of microstructural analysis. So, there is a large list of references available in front of you. There are in this you will find references. For example, the first 3 references are directly on stereology related subject, and the 4th reference you see is a reference on advanced engineering mathematics, and specifically a couple of chapters have been identified in this which are on probability and mathematical statistics. This can provide the necessary mathematical background for this course. The 5th reference by Russ and Dehoff on practical stereology also provides some tools for image processing of microstructure. Subsequently, there are other references which would be quite important for people who want to seriously enter this field. For example, quantitative stereology by Underwood, quantitative microscopy by Dehoff and Rines, Kendall and Moran book on geometrical probability, and people who want to get some idea of the principles of microscopy can have a look at reference number 9 by Goodhue and Humphrey. And then the last 2 references, 10th and 11th, are mathematically quite involved books on stereology. People who actually want to start working or doing perhaps their research in this area would find references number 10th and 11th very useful. With this, I close this introductory talk on this particular course. Thank you.